Determine whether the series is convergent or divergent. We're given the series from 1 to infinity of 1 times 3 times 5, which is 2n minus 1, all over 5 to the nth n factorial. We can rewrite this. And whenever we see a factorial, we always want to use the ratio test, and that is the limit as n approaches infinity of the absolute value of n sub a sub n plus 1 all over a sub n. So we just plug it in. The limit as n approaches infinity of the absolute value of 2 times n plus 1 minus 1 over 5 to the nth plus 1 times n plus 1 factorial, multiply. Then we're multiplying by the reciprocal of this because we're dividing. So it's going to be 5 to the nth times n factorial all over 2n minus 1. So now I'm going to distribute the 2. And that is n approaches infinity. Get 2n plus 2 minus 1 all over 5 to the nth plus 1. And now I'm going to expand this factorial to get n plus 1 times n factorial multiplied by 5 to the nth n factorial over 2n minus 1. Now we can start to cancel things out. Our n factorials go. 5 to the nth goes. This nth term goes. Now we just combine like terms, so we get the limit. As n approaches infinity of the absolute value, we get 2n plus 1 all over 5 n plus 5 times 2n minus 1. Now we have to FOIL this, so we get the limit. As n approaches infinity, the absolute value of 2n plus 1 all over 10n squared minus 5n plus 10n minus 5. I'm going to go all the way back up here. So rewriting this, we get the limit as n approaches infinity of the absolute value of 2n plus 1 all over 10n squared plus 5n minus 5. So now when we put the infinity in, we're going to get infinity over infinity. So now we have to do L'Hopital's rule. So we take the derivative of both the top and the bottom separately. So L'Hopital's, take the limit as n approaches infinity, the absolute value, and take the derivative of 2n plus 1 is just 2. All over 20n plus 5. And then that drops. So now we get 2 over infinity, which is equal to 0. And 0 is less than 1, so by the ratio test, this series is convergent. Of 2n minus 1. It's convergent by the ratio test.